unsupervised learnings in just conceptual, very abstract way. Because yesterday in feedback, many people looks like they are really beginners and do not have any background related to that. What I assumed is there were so many FDP programs across the country past 2 years. I thought like most of you must be knowing a lot of concepts. So try to bring really very new concepts into the session yesterday. In today's session, I will be touch basing upon these basic concepts yesterday's little bit of principles and little bit of this terminology that we are going to use, and then introduce agents and the environment that we are going to start with as basics or basis and foundation on which we will be building whatever we want to build, even if it is autonomous vehicle. These basics or basis of understanding of what kind of system that we are building is given by understanding of environment, or bifurcating or finding out what is the output and what kind of system I have to develop. For that, we need to understand a little bit of agents and a little bit of environment. So that we'll be doing today. So thank you very much for yesterday's feedback. And before I start, I would like to thank the sponsors, Bhimavaram Institute of Engineering and Technology. Thank you very much to the HOD and to the principal sir, and also to the management, Haribabu Garu, who was keen persuading us to take this program. So thank you everyone for this platform where most of the faculty are really trying to take information from this. Good morning, everyone. So let me share my screen and start off from where we left yesterday. Okay, so we start today with, yesterday we have completed history of artificial intelligence. There will be one or two just for refresh. Today we will be dealing with fundamental principles of artificial intelligence, based on which the entire system, whenever you want to design, you will have to base it on the system. So today we'll be having, so as I said yesterday, we have something called Turing Center of Excellence, Alan M. Turing, who is the starter, beginner, father of artificial intelligence. Under his name, we have started in collaboration with International Institute of Digital Technologies, in turn collaborating with George Mason University and Virginia Tech University. We'll be doing a lot of webinars and workshops, and also support faculty in terms of their research, solutioning of their complex problems. So we will be doing all these things in part of as part of Blackbuck's Turing Center of Excellence. And today's feedback form will be having a section. This is free. If you want to become member of this community of Turing's Center of Excellence, you can say yes in that. So we will issue membership to you for Blackbuck's Turing Center of Excellence. And from there on, you will be learning, and you'll also become eligible shortly for doing consulting projects, research. You will get research support and do lots of activities as part of artificial intelligence expertise group. Okay, so take advantage of it. So let me start with fundamental principles of artificial intelligence. So this is the definition that I think is the correct kind of definition. Perceiving. These terms we will be looking in agents and environment also today. Perceiving, these are all biological, psychological things that the names are all same of what you understand the true meaning in the form of human psychology. This perceiving means understanding of things from what is happening. Then being able to classify in the sense, this is cat, this is dog, this is shampoo, things like that. So classifying, then learning from what is happening, abstracting. Now, after learning, the machine, like humans, should also be able to deal with abstract ideas, not just input in terms of numbers or words and output in terms of numbers and words. It also should be able to deal with ideas. That is abstracting. Reasoning on, say, for example, if a machine has to decide, I will take this route. Google Maps will give you 2 or 3 routes to your destination. and you will decide which route you want to take based on which is the shortest route or which is the route which is having very high traffic. So based on reasoning, you decide which place to which route to take. So reasoning and or acting. So and then take the route. So acting means take the route to do the action. Okay, so this is the AI which we are dealing with in the current generation. Totally, probably next 10, 20 years, we will still be stuck up with narrow AI. In general, AI is full autonomy. That means just like any other human being, all aspects of thinking and intelligence will be built into that machine. That is full autonomy. So this is the best definition as far as I have seen as what is artificial intelligence. So this also we have discussed artificial intelligence. Why now? Because of these three main reasons. In most, as I said, most of the lectures and guest lectures I have seen, they tell us that it is mostly because of the increase of computing power or the big data centers that are able to hold data. Of course, it is because of the computing power of your own machines, of the digital computers, and the ability to hold big data, and also the breakthroughs in different methods of artificial intelligence and machine development of artificial intelligence and machine learning. So all the neural networks and multi-agents in neural networks, those, as I have explained yesterday, those number of layers within the neural networks. So these kinds of different breakthroughs in algorithms, all of them constitute the high incidence of artificial intelligence today. Though, so what I have seen in the syllabus, because I'm on board of lot of universities, what I've seen in most of the syllabus is they are still dealing with basic computer science for 2 to 3 years and artificial intelligence very minimal in the final year. So of course, the syllabus of computer science is very, very important for the students. That foundations in computer science is very important, but there should be more of artificial intelligence. Whatever we are teaching today is not sufficient for students to become AI engineers. So, so this is what you have to remember. This is convergence of why we are having so much of convergence of high performance computing, big data and algorithms, that these are the things that are enabling widespread of development in artificial intelligence area. So next, this is the canonical architecture. Another picture that you will have to remember is the canonical architecture. This is entire end-to-end flow of what is happening within the system, and bottom you see the basic foundations or basic infrastructure or thinking that has to be underneath, which uses all these things. So the sensors, you have seen yesterday, the sensors produce the structured data, and there is so much of other sources like YouTube or Facebook or the news or Twitter or so many other general things like your mobile data usage or our Zoom videos, which we are having now. All these also produce a lot of data. That is unstructured data. So the structured data and unstructured data together go to this data mart. And in this data mart, you have to do data conditioning. And this is where most of your students, when they get into data science or machine learning or artificial intelligence jobs, most of the work, 80% of the work will be done in data conditioning. And yesterday I have also mentioned that if you are really interested in a center of excellence in your college and you want to do lots of research, you should focus more on data first, and you will be getting a lot of projects from the companies if you focus on data conditioning. You just go and pitch data conditioning instead of artificial intelligence capabilities. There will be lots of people who will be ready to give you conditioning consulting projects. Next is algorithms. So in algorithms, you have knowledge-based, supervised, unsupervised, and reinforcement learning, transfer learning. So the basic knowledge is supervised, unsupervised. There are so many developments over this supervised and unsupervised knowledge. These are the new developments that are happening, etc. Is the new developments happening? Even reinforcement learning, transfer learning are how you actually fine tune and make efficient of all what algorithms you use in as based of knowledge based and supervised. They have come with new names, which are transfer learning and reinforcement learning. Next comes this human machine teaming, and that is the next slide. We will briefly talk about it. Humans have certain certain kind of intelligence, and the speed and automation is what is done by machine. But there is in between area where humans and machines can collaborate and produce wonders. So that is human machine teaming. And all these things together get into the users for various, say, military or climate change or autonomous cars or health and producing of, and in pharma, producing of various medical things for the pharma. So all these things, and even, you all must have seen these videos of machines operating, though I don't trust my heart operation in case at all it has with the machine, but we do not, I don't want you to restrict it. They all are very, very efficient. Okay, so then modern computing, as we said, these all are possible with the help of these modern computing techniques. And what are those modern techniques? You all know CPUs, we still use CPUs. And I told you yesterday, you have to start moving towards GPU. Either purchase cloud in cloud, which offers you GPU, and we will provide that if you want. Or there are new things coming for tensor processing unit is from Google, which is very much, which helps you now that what kind of processing power you need, what kind of processing you do, how the processing units have to interact with each other is well known. So based on that, very good processing units are being developed, researched and developed. TPU is tensor processing unit, which is very efficient for your AI-based projects. And then neuromorphic, it is very, it is the next level for your neural networks-based processing units. So like this, and even custom, people make custom, probably we are not there yet to make somebody develop chips and processing units based on our needs. So there is a lot of happening around custom development. And of course, you all know quantum development also. So now explainable artificial intelligence we need, because at this moment, explainable artificial intelligence is nothing but you will understand why a machine has behaved in a way, in the way it has behaved. It is not unexplainable. Say, for example, we heard news from Facebook saying 2 of its robots are talking to each other in a language unknown to human beings, and then they have scrapped the project. Things like that we have heard, but you can always explain it is a code written by human beings, but again, code written by machine learning, you can trace it back to what code we have written. So explainable artificial intelligence at the moment, and metrics and bias assessment. So after you produce results, the output, you will have to always measure and see what is bias. There is huge uproar in the West, where the face recognition algorithms are not able to recognize black faces. They are only able to recognize white faces. So obviously there is a bias there. So whoever is coding, we are all with our biases in our minds. We have so many regional and race and all those biases in the mind. So there is that bias unknowingly or unknowingly enters into the coding of machines and robots. So you have to see metrics and bias assessment, not only the human bias or psychological biases. Your algorithm might be developed biasing some kind of results. So you want it showing that this result has to show. See, I told you that this corona vaccine will result in heart attack, and you will program in a way that it shows that corona results in a heart attack. So there are lots of biases put into into a machine learning by the human who actually codes it. So that bias, you have to look into that bias assessment, and you will have to verify and validate whether whatever you have done are really true. Then in actually we are just dealing in this 5 days or 6 days with the introduction. But if you go into detail and when you see the statistics related to the data science, you will also see the confidence levels. And also you will see how far it is true and all these things. So you will have to put up verification and validation aspects and do proper testing of your models. Next is also inculcate security. As I said, like there will be so many things that come into picture. The Facebook thing, where two robots are talking in an unknown language to each other, they are able to understand each other. So you'll also have to put those security aspects in it. Also put security aspects that nobody hacks your machine learning and artificial intelligence algorithms. Then the policy, ethics, safety, and training. We don't know yet. Say, for example, a car is being driven. The autonomous car is driving over a cliff with you, with or one person in the car on a cliff, on a mountain. There is only just little small road on a mountain. While it is driving, suddenly a boy comes running in front of it. Should you hit the boy or should you fall into the valley? Who knows? Okay, you can't code it at that particular point of moment, depending on a person. Even if I'm very nice, I will fall into the valley and save the boy. Or at that moment, my mind says, just go on. I'm not able to put the brake. The boy is hit. Then also code says nothing. Code says, it is an accident. But if you willfully program, who is going to program that I will hit the boy and not fall into the valley, then you are not right. So a lot of things around ethics, safety, and all these things are not yet, the policies are not yet set by any of these autonomous car developers or any artificial intelligence activity that is happening. It is still evolving. All these are not set. So this is the canonical architecture that you will have to remember the entire artificial intelligence space. So it is 11:30. So anybody who has any questions, kindly stop me and let me know. I'm just checking the chat box. Anybody has questions, please type. I'm just having a sip of water. Give me a minute. Okay, looks like nobody has questions. Okay, let me go back. Okay, faculty, are you listening? Please type S if you are listening. I want to see just S in case you are listening. So faculty, thank you so much, Madhuri ma'am, Swati ma'am. Okay, thank you so much. What I have seen is today there are around 230. Yesterday there were around 230 people, but the feedback came from 500 faculty. So always I have observed that faculty, when they come for faculty development program, almost become students again. So okay, anyway, thanks for being good students, also bad students, because 500, only 230 people came and around 500 feedback we have got actually. Okay, anyway, here we are, the history of artificial intelligence. So here I would like to show you a few things. So this is what we spoke about, 1950, computing machinery and intelligence, Turing test published. This is what we have seen. And then we also saw Frank Rosenbelt, the huge wires, which he was doing analog machines for finding out triangle, circle. So Frank Rosenblatt we have seen. And the first computer, 1957, test computer to simulate operation of neural networks has happened. And in 1960, recognizing handwritten characters by Robert Larson of SRI AI Center has happened for recognizing handwritten characteristics. And I just want, this Blackbuck Turing Center of Excellence to do really good work going forward. Our CTO is working on prosthetic limbs. So he works on prosthetic limbs. Now, if your mind thinks that your hand has to move, it moves. But for artificial hand, it doesn't move. So he is working on a prosthetic limb which moves if your mind thinks it has to move. So few good things we are doing. Possibly you'll all take part in those developments. So expert system pioneer Dendrol project has started, then convolution neural networks has started, and neural networks was actually silent for a lot of time. As I said, there was one publication which really really hit everybody on their head on no neural networks, it is not going to work. So then 1986 onwards, again somebody has picked it and started written of neural networks, expert systems, hidden Markov models and convolution. So all these have started. And we spoke about how in 1997, Deep Blue defeated chess champion Garry Kasparov. Then what is this DARPA challenge? 2001 big data, if you, that particular point of time, 2001 to 2007, 8, every training institute, if you travel through Amirpet in Hyderabad, it is all big data, Hadoop, this period of time. And then 2007, DARPA Grand Challenge. So what is DARPA Grand Challenge? There will be lots of videos in YouTube. You can look at DARPA Grand Challenge. It is to help miners, excavations. So they have made robots which will go deep, or drainage also. Unfortunately, we still have sewage people in India. So in the DARPA Grand Challenge, it will go to those places where humans don't want to go. Inside the miners, to rescue the miners, to bring certain things from deep inside the earth. So this is that DARPA Grand Challenge. You can see how people were trying to make good robots like the football robo yesterday. Okay, and this we have seen yesterday, Geoff Hinton's lab. Anybody has gone through his works or papers? If you haven't, please go through his. So he has taken ImageNet, and we have seen how it has to label the images. So ImageNet large-scale virtual recognition challenge. His team has won it, and he is the first person who has actually given momentum to artificial intelligence. And he has democratized, in the sense, from 2012 or even 2018-19 is when artificial intelligence has started reaching more people. It was limited to extremely intelligent and extremely hardworking researchers. Okay, so after that, 2016 also there was one grand challenge. Okay, and we have seen this also. IBM Batson defeats former Jeopardy champions. Jeopardy is nothing but, I told you, like Kaun Banega Crorepati. So it is a quiz one which IBM Batson has defeated, and then DeepMind AlphaGo, that in 2016. So this is the history of artificial intelligence in one screen. So you can give it to your students with this one screen, and they can easily prepare for their exams. And this is what is this person, the DARPA director. The DARPA is the same thing, the robots which go deep into the earth. So he is this director of DARPA challenge, and he has he has defined artificial intelligence evolution into these 4: reasoning, learning, context, and abstraction. These things are very important for our today's discussion of agents and environment. So what is reasoning, learning, context, and abstraction? Reasoning is where you have handcrafted knowledge, you have expert systems where you have non-expert systems. Expert systems are already there. So you have non-expert systems understanding and reasoning why I will have to take a particular route. Okay, this is handcrafted knowledge. Learning is statistical learning. That is why we have thought that statistics and probability becomes very, very important for you, for the students to understand or to even teach. It becomes very important for you to at least go till the place of the Bayesian models and certain kinds of tests. So all these things we'll have to at least to a level of statistical teaching, we have to make the students learn properly. So learning, statistical learning, then context. What is contextual adaptation? Say you are able to recognize a chair. I can recognize this is a chair. But what is context? If you put it near a dining table, it will be able to understand, okay, this is a dining chair, or this is an office chair. So it is able to put a context around the chair. That is contextual adaptation. So you will perceive, you will learn, you will also understand the idea of dining, and then you will also have reasoning. If you see, this is where you have reasonable intelligence in the context place. And abstraction is totally, you will be able to understand these people are going to have a party because you have seen so many dishes on the table. So you are able to understand things through multiple angles. That is abstraction. A concept or an idea is what you are able to understand. So this is 4 waves of artificial intelligence that he has said, like this is the evolution. We have these 4 waves. Not that we always probably know industry 1, industry 2, 3, 4, industry 1. After that 2 has come, after that 3 has come, after that 4 has come. But here if you see, nothing is complete. It is not that reasoning is completely developed. That is why we went to learning. Learning is completely developed. It is not like that. Everything is happening simultaneously and everything is in very, very mini stage of development. Okay. So any questions? Let me check actually. Okay, thank you. So this is the commercial organizations. Yesterday we have seen tools. These are the commercial organizations which are utilizing various kind of abstraction. Pragya ma'am, abstraction is nothing but having a complete idea or concept in mind. There is no clear-cut explanation as to why you are thinking in a way that you are thinking. It is a total idea. So if you give a picture of a room to a computer, probably it can identify there is a chair. Okay, it will label it as chair. Okay, or if you give a sports picture, it will say probably human. This is Mrs. Prag, this is Miss Pragya, this is Rubia. So like this, it will identify. But this is a total concept of idea. Abstraction is, so it will be also able to tell that this is a dining table and here we are going to have it. There is supposed to have a party because I see lot of dishes there and a lot of activity around. So abstraction is total idea. It is not a single 1 point input, 1 point output. It is a total system, total context and total idea about that context. There is predefined learning about that room, predefined learning about the dishes, predefined learning about a party. There is so much that you learn as you grow. Why you are able to understand so many things. Your college, what happens in the college, how is the climate. While you travel from your home to college, so many things you can understand. You don't even pay attention to what you are understanding. You all know it. How do you know all these things? Because you have the predefined knowledge of so many things. It means that this is May, that means it will be very hot, or I'll have to carry an umbrella if it is raining. So you have so much of learning all those things. So it is a total understanding of a system, and abstraction is, there is no clear-cut definition. It is just an idea of existence of something. Okay, Pragya ma'am? Okay, all right. So let us move on to this. If you see spectrum of commercial organizations in the machine intelligence field. So you see there are so many things. For customer support. For customer support, there is a lot of machine intelligence. You can understand your customer on what kind of questions they will ask. So you will also know through these chatbots, right? So what kind of questions they will ask. You will have predefined answers for it. So when I was programming for a particular company called National Grid, it is like gas. The question is smell gas, call this number. So there are so many call center people, around 50, 60 people were answering those people in UK. These people will be answering the calls, whoever calls up. So we'll have to program on this entire branch, we will have to develop. That means the first question comes, this person will ask, do you smell gas? Then the answers will be yes, no. If it is yes, then the next questions will be like this entire branch of questions we have coded. It is a bunch of if then else statements in simple words. But what machine learning systems will do is, from the questions it will learn. So somebody will ask a question and then you will answer, and somebody will ask another question. Then at this moment, the machine does not have answer, but it will learn. For next time, it will learn, okay, this will be the question and this should be the answer. It keeps learning every day with every question. That is the difference between earlier coding mechanisms and today's coding mechanisms. So for customer support, then sales, marketing, for everything, every single thing. I mean, like we can take examples of each one of this, but unfortunately we wouldn't have much time over that. So every single place we will be we are already using machine learning, artificial intelligence, and data science in this. Monica, madam, you have raised your hand. If there is anything, please type here, or you can unmute yourself and ask the question. So autonomous systems, healthcare, enterprise intelligence. Healthcare especially is actually the hotbed of development. Healthcare for artificial intelligence, especially data science and machine learning, healthcare is the hotbed. As I have explained yesterday, because I have this 3.5 crores of data of people, it is all masked. I won't have the person name or number or nothing. I'll be having just age group, area, mask. It's called masked data. Anybody gives me data, they give masked data. So now I will be having all the data with the age, where they live, what is their income, what is their lifestyle, how much they spend monthly, what kind of medicines they take. This so much of data I'll be having. Based on this, and I will be start from now. Even if I have the data, I will be able to find out and tell these kind of people will be getting these kind of diseases. Again, we call something like CD, NCD, communicable diseases, non-communicable diseases. So lifestyle diseases will be few like non-communicable diseases. So we will be making list of all this and keep studying those data. As you fill this information with what kind of diseases they have got, going forward, you will be able to almost restrict that person's health issues. That is what happens. Like what happens in Japan is every 6 months, a person has to get complete health checkup. And even if that person increases by 1 kilo weight from the ideal weight, the government will give them prescriptions on how to manage it. So if you have lots of this data, you can really find out what kind of medicines will be suitable for what kind of people. All this beautiful data you can have, and they are killing it. Healthcare people have taken the entire data science and machine learning by storm. They are using it very well, actually. So, and that lot of technology organizations also will be using. So this is the broad spectrum of commercial organizations in machine intelligence field. Okay, as I said, we were talking about 3 important things. Can somebody type me what are those 3 important things which have helped growth of artificial intelligence in this age, in the past few years? Why it has grown so much? What are those 3 things? So infrastructure, our digital computers, development in technology. One is digital computers, then handling big data. It is general corporate companies, but what we have discussed is the three important aspects which have helped artificial intelligence to really become such an important field is ability to generate and handle data, which is big data. And second is our digital computers and infrastructure, the big data centers. And the third one is breakthrough developments in algorithms of machine learning. Yes, yes, yeah. So, yeah. So, of course, yeah. So, Dr. Shirina ma'am, you are, I thought like you are 7 by 10 and be so naive and you will not like the lectures. Thanks for coming back. So, yeah, these are real reasons. And here is one very big reason, the underlying reason is the generating data. And you see breakthroughs as the availability of data becomes, yeah, Sri Lakshmi ma'am, true. As the availability of data becomes more and more, the breakthroughs in AI have become more and more actually. So this is, here is where you can see how data sets availability and breakthroughs in AI have been parallelly developing side by side. Okay. So here we have, I want, the esteemed faculty here to figure out some strange thing on this aspect, the structured data types and unstructured data types. Is there anything strange that you see in structured data type and unstructured data type? Earlier, when I used to tell people or do guest lectures or things like that, when I tell, I used to tell what is structured data type. I used to tell the data that is generated in organizations, say retail, you generate in a very structured fashion. Numbers are numbers, and they are clearly in Oracle kind of databases, where or SQL kinds of databases where it is organized in tables. And clearly each item has, each number has a reason. It has a table column head, like this is an ID, or this is employee ID, or this is employee salary, employee name. You can identify each of those numbers or names available or data available in that. You can identify. That is very much structured data at that time. All else is used to be unstructured, like what you get on Twitter or what you hear, our video which we are generating right now, the text which is being generated here in the comments tab. All this is unstructured data earlier. Suddenly, from this past few months, I have started putting speech in structured data types. How can speech be structured data type? What I am talking now, the speech is a structured data type now. That is because they have already found out how to make this structure. How to make this structured, they have already found out. You give a speech to a database, it will make a structure out of it. It will convert it into, the speech is converted into text, the text is converted into and labeled and highlighted. It takes most repeated words. Everything it will take it from it and give to us. It has become structured data type. Sensors provide data, network logs, all these things provide data. What is unstructured data type? There are a lot of reports that come, say for example, MRI scans. There are a lot of doctor reports. There are a lot of our own white papers or publications that you do. So the reports and the human behavior, whatever is happening currently, how do you structure human behavior? You cannot structure. There is a cyber person doing so many things every day. Cyber criminal, we can't structure it. So there are, social media is also unstructured. Especially there are algorithms now, but if you see Twitter, there are so many sarcastic tweets. So if there is something really bad, they'll say, wow, what a beauty. Really really bad, they will say like that, that's a sarcasm. How do you, just with words, how do you mark it as positive comment or a negative comment? So there is lot of unstructured data type and structured data types. Then here is where I said, please try to concentrate on this for your research centers, data conditioning or storage technologies. So you will be having the infrastructure or databases. You will have to the capabilities that you can provide, or these databases will provide at this moment, and you can enhance it is indexing, the structure, domain specific languages. I myself didn't know this, and recently I have tried this in Google Translate. In Google Translate, there is, oh, I'll show you actually all right. I'm sure many of us don't know that. So I have Google Translator here. Okay. And this is the website, the blackbucks.com. I have this website. Okay, so this is the website ours. Don't just get a job, get a high paying job. And then you have a number of things over here. Growing global network, Blackbuck learning. So you see all these things. Now what I'm doing is I'm converting my website, the blackbucks.com. Go. I think campus success platform. ప్రపంచ స్థాయి learning dream career అపరిమిత వినోదం. Dream career, everything is such word to word and correct kind of trans. కేవలం ఉద్యోగం సంపాదించుకోవద్దు, అధిక జీతంతో కూడిన వృత్తిని పొందండి. పెరుగుతున్న గ్లోబల్ నెట్వర్క్. Blackbuck లెర్నింగ్ ఇప్పుడు ప్రపంచ స్థాయి పాఠ్యాంశాలను అన్వేషించండి. In a minute, they have converted in entire notes. Now I'm planning like blackbucks.com/t, which converts Telugu into Telugu, dash HI into Hindi, dash like this. I'm planning to have it. It is a minute's job. It's a minute's job to convert entire website into a proper language. It is not even hilarious anymore. It was hilarious at a particular point of time. If you see this YouTube, some songs being translated into English, then definitely it is very hilarious. But if it is not hilarious anymore, and who taught it how to convert entire sentences? Who taught Google or Google Translator every word and every sentence? How to? Nobody taught. It doesn't have grammar lexicon books, or it doesn't have grammar teachers who has incorporated grammars, nothing. Whatever we type in Telugu, it has taken, it has understood, it now understands how to translate, and it has translated. Okay, so let us go back to this. Okay. Okay, so here the domain specific languages, high performance data access, declarative interfaces. In all these places, there is a lot of work being done, and you can think about it. And data curation is one place, unsupervised machine learning. These are all capabilities provided, and a dimensionality reduction, clustering or pattern recognition, outlier detection. So most of you, I am assuming you know that But however, if you do not know 2-3 words about what are these, so supervised and unsupervised is just that I have told madam how she has learned from her childhood till now various aspects about you have to carry an umbrella, or if you speak in front of large audience, some people will laugh at you and then you stop speaking in front of large audience, or sometimes you probably learn from it and learn how to speak. So there are so many things that are unsupervised. Supervised is as a mom or dad, you help your child understand this is cat, this is dog, and you give that information to the boy, and the boy starts learning about cat and dog. And for unsupervised is what you learn by yourself, or the child learns by himself or herself when growing. That is supervised and unsupervised machine learning. And dimensionality reduction, it is another important aspect, and lots of corporate will be looking out for help from academia, is dimensionality reduction. Why dimensionality reduction? The more parameters you have, you think is influencing one aspect. Like say for example, you want to find out why there is lot of crime on women in some particular area, and you give education, literacy, or and then the economic conditions, blah blah. You have some 20 parameters you have for that dimensions. It becomes very difficult to predict. It becomes very difficult to classify and predict everything. To arrive at proper answers, it becomes very difficult. So the number of dimensions you deal with should be reduced. That is called dimensionality reduction. And clustering and pattern recognition, what you will be, somebody will be teaching you supervised and unsupervised at a broader level on day 4 or day 5. This is just an introduction. Clustering and pattern recognition. What is clustering and pattern recognition? So your shop will identify that somebody who is buying Johnson's baby oil is also buying Johnson's baby soap. So what they can do, they can use that to put them together into one packet and sell. If you buy these two, you will get so and so discount. Okay, they will use for various purposes, but this is clustering. So here you see that picture, small picture, how they have clustered data into 3 different buckets. So clustering and pattern recognition, and outlier detection. Outlier detection, you all must be knowing in statistics. There is something which is, so in entire class is anywhere between, heights are anywhere between 5 to 5.8. There is one person who is 6.5. So you don't want that 6.5% to skew the average size of your entire class. So that is outlier detection. So yesterday, thank you everyone, I have got really very good 4 and 5 ratings. Many of them were 5 and it came to around 4.6566 or something like that. Thank you everyone for the rating. But somebody has given 1. So I do not, that will skew, and I was very thinking if I just remove this one, the rating will be high. So it is like this, you don't want to consider that outlier detection. Okay, and then data labeling, like I have said, the ImageNet thing. So you can label the data for various purposes, further research. So highlight missing or incomplete data. This is data curation we were talking about. Missing or incomplete data, reorient sensors or recapture data. You have to give it back to sensors. Oh, I don't want data like this, or I don't want this data, give me some other data. And look for errors and biases in collection. So this is all you will have to, you can develop capabilities in this before going to developing an autonomous car or something like that. You can apply on any website. Okay. So, okay, let us get into this. We'll go again back this machine when we go for machine learning. I am quickly moving into today's classes because madams have started asking me to give feedback form. So I'm just moving into the next section. So before we move into next section, please, this slide I would like to tell you before I move into the next section. So earlier, what traditional programming and machine programming, many might have you already told, but please remember this. Earlier, we used to give data, we used to give the program. That means this is an addition program. You give 2, 3 and you write code for adding, you will get the output. But here in machine learning, what happens is you also give data and also you give output. That means, say for example, if you are giving the computer list of all people who have applied for credit cards in my bank. So I'll give all the data. This person education is like this, job is like this, monthly income is like this, married, house owner, all these things I will give to the data. And output, I'll also give the output. What is the output? Give me whether that I can give credit card to this such new person or not. So it will take the data of all that person. It will know. So what you're giving is data, output, and you're asking the machine to program by itself. And this program, doesn't end here. The output again, it will correct itself and this flow keeps flowing round and round and round because it is a learning system. Okay, this one I wanted to, so if somebody wants to talk, that I was sent a message. So if anybody wants to talk, please, you can stop, another half an hour to go. So anybody wants to talk, please go ahead. But one question before we are going to the next. Can you share the PPTs of today's session? I will share definitely. Let me complete. Okay, probably till this point, 2 I will share. The next point starts today, environment and agents and search. Search, please be prepared tomorrow. It is going to take a little bit of your complete attention, because you will have to carefully observe what each algorithm means. There are only minor changes between these algorithms. That is what we have to note, and that is where students struggle. So tomorrow you need to have your complete attention. So environment and agents is what we are going to discuss today. This is what we have completed. Actually, this is history and fundamentals of artificial intelligence. So an AI system, now we are going into a more real, true way of understanding. What is an AI system? Difference between artificial intelligence and machine learning. Okay. Okay, so once, take the example of YouTube. YouTube is gathering information related to what I'm watching every day. You and your family probably will watch common movies, but again, you also watch different movies separately or news separately. So, mention some books. Of course, yes, I will do. So, so YouTube is one thing which is collecting data. Then it is processing the data of every person who is watching YouTube. It is collecting data and processing the data. All these things which we have talked, curating data and all these things, it is collecting data. Now, after collecting the data, it is also learning, because it is giving different recommendations to your family and different recommendations to you. It is learning specifically about you, also specifically about the family. Okay, so it is learning about you and also changing its recommendations according to it. That is machine learning. So data science, then that data feeds into machine learning. And after machine learning, this machine, whatever it has learned, you are putting into a system which can use it and automate it, use it in various ways, like computer vision. What is computer vision? There are few aspects in artificial intelligence, not only this, it is beyond that. But say, for example, computer vision comes under artificial intelligence. What does computer vision do? Say, for example, if you put an AI system in a mall and you ask to track one missing girl, one missing small girl or boy, if you ask it to track, it will start tracking from particular period of time in last 1 hour, how this person has moved throughout the mall. Computer vision does that. Okay, so it can exist even without machine learning. There are certain expert systems that artificial intelligence can actually prepare without existence of data science and machine learning. Machine learning cannot exist without data science because it has to learn from the data. So data science and machine learning are a little bit thick friends. Artificial intelligence can develop certain expert systems, like you develop a robot which picks dirt in your home, which picks obstacles in a factory. It can exist even without artificial intelligence, but it can also exist when it combines with machine learning. The automation becomes very powerful. Okay, so I will show you what all systems. Autonomous car is one system which also has a lot of machinery which is based on learning of machine learning. So you can imagine like this: data science and machine learning together, and artificial intelligence is a little bit bigger because there are so many aspects outside machine learning and data science which artificial intelligence can do. But with machine learning and data science, artificial intelligence can really make powerful systems. Okay, please share feedback from it since they have a class. Venkatramanan sir, actually they will share even in the group. If you are in the group, you can fill it later. So I can mention some books. I will put it in the group, Sunita ma'am. Resources to get exposure on, yeah, I will do. Okay, so this is what you will have to learn for today is environment types and agents, which we'll use tomorrow for search algorithms. Search is very important because that is how it is not for just searching like what we do in Google. The concept of search is used in various aspects, even in neural networks. So to find the right neural network also you will use search. Search is very important. So tomorrow that strong foundation comes tomorrow. Okay, so tomorrow is very important class. Kindly be there. So environment types are this is the environment in which an AI machine works. Environment is nothing but where the AI machine works. What are different environment types? These are fully observable versus partially observable. Deterministic versus stochastic. Let us go with step by step. So what is fully observable versus partially observable? So when an agent sensor is capable to sense or access complete state of an agent, it is called fully observable. That means, say for example, the vacuum cleaner. If you put a vacuum cleaner, or even you can think about chessboard has fully observable states of that environment. In a chessboard, you know that limited number of playing players and limited number, and all environment is limited. Only 2 people will be there. Only so many so much area to travel around. Only so many steps have to be put by each. So like this, you have everything defined. That is a fully observable environment. What is non-observable environment? Non-observable environment is of a, say, car. If an autonomous car is traveling, the car wouldn't know what is happening in the corner. When it hits a road, and it doesn't know what happens in the corner of the road. So here is a small example, probably you can see. So this is fully observable, limited space. And what happens here? You don't know what is happening behind sometimes if it is an autonomous car. Okay, so fully observable versus partially observable. Next, you have deterministic versus stochastic. Once you define a artificial intelligence problem or project that you want to work on, you will have to see what you are working on so that right algorithms you can apply. What is deterministic? What is stochastic? So deterministic is the current state completely determines next state. That means in your chess, when you are doing the first step, it determines what will happen in the next step by your opponent. So the current agent's state will determine what happens in the next state of the agent. That is being deterministic. Stochastic is you do not know. The environment in which the machine is operating is random. What happens next, nobody knows. So what are the examples? Anybody can want to type the example of stochastic environment? You don't know what happens next. Natural calamities. Of course, yes, you wouldn't know when you will come. And these natural calamities happen at home also. Observe the boy and observe the girl. So the natural calamity happens at home. Okay, stock prices. I really, Sri Vallabhadev sir, it is very true that stock prices don't depend on anything actually. So deterministic versus stochastic is this. So going next, model-based reflex agents. Oh, why did it come here? I went. Okay, I don't know why it went so far. Okay, next is competitive versus collaborative. So when an agent is a competing environment, so what happens is you have to optimize the output. The game of chess is competitive. So if two agents are playing, then they are competing with each other. Collaborative environment is they have to collaborate, otherwise they will collide and they will actually fail. So this is what you see. Competitive is you have to compete with each other. Collaborative is they have to collaborate. They cannot collide with each other, compete and collide with each other. They have to understand the other person is traveling at so speed, so much of distance. So I have to maintain so much of distance. So it has to see. This is competitive versus collaborative. Next, single agent versus multiple agent. Okay, so this is self-explanatory. If an environment has only one agent, it is called single agent. If the environment is involving multiple agents, it is called multi-agent. So this maze, when you have to travel from end to end and find out the place how you go out. This is a single agent. Only one player is playing there. One agent is playing there. But if you see football, it is multi-agent. Yesterday we have seen that football game of the robots. It is a multi-agent one. Okay, and dynamic versus static. So an environment that keeps changing continuously is dynamic, and ideal environment that doesn't change is static. Okay, so how is dynamic environment? This keep changing. So if I am there, it doesn't mean that I am there. If the ball is there, it doesn't mean only I will play, somebody else will hit it. So this is dynamic environment, this is static environment. Discrete versus continuous. What is discrete? What is continuous? Discrete is there are only finite number of actions. You can take only limited number of actions. The game of chess is easy to code. Yesterday also I have said it is easy to code because you know the finite number of moves. The decision might change. You can use those if else. So the decision might change, but it is finite number of moves. But self-driving car is a continuous environment. It is not discrete. You can't number. You cannot give. So in chess you can say there are 10 moves or 20 moves. Or if you go this route, there will be 100 moves. You can say that. In self-driving car, you cannot say, you cannot number it. So discrete versus continuous. Okay, and episodic versus sequential. So in episodic task environment, everything is episodes. This is done. I don't remember anything more from that. It is done, it is complete. My previous action doesn't influence my current action. In a sequential environment, my previous action will actually influence my next action. So episodic is, say for example, I think I have put some examples. This is episode. I have picked something, I have picked something. That's it. My previous thing doesn't tell me anything else. I have picked, that's it. This is episodic. Sequential is next step, that is sequential. So coming to agents. Why am I going to end? Yeah. Okay, so agents are in this environment, you will put agents to work on it. So what are these agents? So let us go to what are these agents. Agents is anything that can be viewed as perceiving its environment through sensors and acting upon that environment through actuators. There are two things here, sensors and activators. So how does human perceive things? There are, say, human versus robot. Let us see this. Human perceive things with their own sensors. What are their sensors? Eyes, ears, and other actuators. What are the actuators which will actually make the output manifest? How do you manifest the output after you see through eyes? You see with your eyes, you see a snake. What happens? You run with your legs. So that is the sensors and actuators. What happens in robot? In robot, you have sensors which are cameras and infrared and actuators. That means various motors which move. So these are agents. Agents, we are also agents. Human is an agent, robotic is an agent, and software is an agent. There are three kinds of agents. So software agent, what it takes, the keystrokes, file contents, these are how it gets information, and our screen is how you get the output. And human agent, eyes, ears, other organs are sensors, and hands, legs, mouth, they are all actuators. Robotic agent, cameras are cameras and infrared, whatever, all the sensors are agents, and various sensors and various motors are actuators. So that is about, there are another two terms you have to know is percepts and effectors. What is a percept? What is an effector? So perception, as same as the psychological perception. Perception is include, so from sensors, cameras, microphones, keyboards, whatever information you get and whatever you are able to understand from the depth, the object, face, gesture, from all these things, whatever you are able to understand, that is perceptor or the sensor sends you that information. What is effector? Effector is the biological meaning is bodily tissue or organ that becomes active in response to stimulation. That is effector. So in robo case also, what you use to answer or give the output for the input you have got is effector. So these are perceptors and effectors. In agent, again, what is a rational agent? A rational agent is a thing that makes decisions. It carries out an action. That is based on the thinking and based on probably some intelligent rational thinking. The agent answers, so it is called rational agent. So if you see, there is an environment, there is an agent. The agent gets information from sensors. It is probably any sensor, probably the visual sensor or anything, whatever sensors our mobile will be having, all those sensors you can count. So you get information from that and use these different kinds of effectors. Probably if it is a robot, it has hands and legs. If it is a machine, it has just a screen. So different kinds of effectors. So environment gives percepts into the agent. Agent through effectors produces actions into the environment. This is how environment and agent will work together. So there are different kinds of agents. With this we will end today. 10 more minutes. I will end with this different types of agents. simple reflex agents, model-based, goal-based, utility-based learning agent. Okay, what are simple reflex? This is the most simplest form of all kinds of agents. So as I said, that paper picking robo in a college keeps picking papers wherever it is thrown. Okay, so it doesn't think about any other thing. Its activity is, if I see paper, I will pick and put it here. That is the rest of the history, and only on the current concept. Whatever you see now, you work. It is like our if then else. Condition, action. If you see this, do this. If you see this, do this. Like this, it is based on condition, action, rule. Okay, and you put your now your understanding of environments into agents. So if an environment is observable, only then this will work. You should have complete understanding of the environment. Okay, then only this will work. This is how very common representation, you can use these slides for your own teaching. So okay, very common representation of environment and agent behavior in this complete setup. So what happens? You will, from through percepts, through sensors, you will understand what the world is right now. There is a paper. What action should I do now? There is conditions, rules you have set up already in the system. It will say the rule is that you have to pick it through actuators. That means that with robo arms, it will pick and remove it from the environment. So this is how it works. It is the most simplest form. Next is model-based reflex agent. Any questions related to environment? Okay, let's get on to the next. So model-based reflex agents. Okay. Okay, model-based reflex agents is like when condition matches the current situation. Okay, so it also observes partially observable environments. Okay, so it has internally certain kind of conditions preset, like the autonomous car has preset. If there is a red light, you will have to stop. If it is green light, you will have to continue. So it is observable environment, but it doesn't happen then and there. There are set of rules inside the agent in its internal state, and it stores it. So based on that, it will actually behave, and it will take a decision then and there. So it will also keep updating itself. It will keep updating itself how the world is evolving independently from the agent. So it is not just my world, it is the world of so many humans, so many other autonomous cars. So how is it evolving independent of me? Is there more traffic? Then I will have to reduce my speed. Is there less traffic? I should go like this. Is there a blocker? Then I will take another route. So there are certain kind of actually certain kind of conditions that are already put into the system. Somebody is chanting. Somebody is saying no. Okay, about the question. Okay. So agents, actions, effect based on it. So this is the representation for this. So what it happens for goal-based action. What is the first one? Simple. It is simple. The first one is the most simple one. It is just if then else. If you see this, do this. If you see this, so it's a simple reflex. Now this is goal-based. What will a goal-based one do? It will take again through the percepts, the sensors, what the world is now. There is a state. How the world evolves is pre-programmed. What I should do. It checks for what is the state now and what is the world now and what should my action and what action should I do now. That action rules it takes, and through the actuators it provides the actions. Okay, there is more amount of information about the state given into your AI agent here. If you see here on topmost left hand side, entire route is actually programmed and it knows how to travel. And it now has already also knows where to stop. So there was suddenly a stop somewhere, it has stopped there. See, it has stopped here. So entire information about the environment, about the route is programmed into the system. Okay, so that is model-based reflex. I'm sorry, I think I said goal-based. This is model-based reflex. So the entire model is put into the system, and based on that model, it will work. So just remember this example that the entire route is put into that, so that there are so many names, it will really confuse us. So just map in your brains model-based with this kind of route programmed into the autonomous car. Now, goal-based agent. Goal-based agent is little bit, it takes decisions a little bit more, one step ahead than model-based agent. What does it do? So it thinks about, I will have to go from this place to this place, or if it is a I'll give the example as we go to the next slide. So there are so many possibilities. If I have to, the Google Map possibility, I can go in so many possible ways. But for reaching my goal, what is the best? Okay, my every action is intended to reduce the distance from my goal. I have to search a hospital. So my every action, next step is dependent on finding out what is the next step. Next step to take to go to the next goal. Okay. Okay. So here you can see the Mars rover. So it has to go to a next step. But what will happen? See what will happen. There is a pit. There is a pit. What should it do when a pit comes or when a hill comes? What it should do? So let us go to this one also. You have to see this is the next representation. What is the difference between the previous representation and this representation? Is you will also put the decision factor here. What it will be like if I do action A, or what it will be like if I do action B. It will have to take various. Somebody might have programmed in Mars rover. If there is a pit, then you will have to do action A, action B, action C, action D. So it has to decide then and there, depending on various parameters. I have to go to that place. For this reason, should I take action A or action B or action C? So what action will you take? Whichever makes your goal nearer, that action you will take. So what is the difference between the previous one and this one? Goal-based, model-based to goal-based is you will have to decide on what it will be like if I do action A, and then you will have to, depending on your goal, on your next goal, you have to take that action and do that action. You can use any language to program this, Pragya ma'am. Probably I will ask in the next, in the 4th or 5th class to do a small action here. Small program I'll ask them to perform online. Utility-based agent. So what we have seen, simple, model-based, goal-based. There is a slight difference between all these three. Simple doesn't remember the environment. Model-based remembers entire environment, how it is going to be, like the autonomous car. And then we have seen goal-based, that the Mars rover has to travel the Mars certain area on it. So it will decide on various options it has. Should I stop? Should I go? Should I fall? All these things it will decide based on whether it will reach the final or not. Next, finally, it is utility-based agents. One more minute, I'll also stop, 12:30. Utility-based agents. So just having goals isn't good enough. utility is not about, reaching the goal is not just enough, right? There is quicker way, safer way, cheaper way. That's how you decide which way to go in Google Maps. What is the quicker way, or sometimes what is the safer way to go? If there is too much of traffic or there is some kind of dharna happening, you wouldn't choose that road. So we'll choose depending on various information that we have or our own benefit. So what you will be doing is, which one is the best on utility based agents? Somebody will call it happiness. So what gives the agent most happiness is what they will have to decide. This is utility based agent. So how do you define utility based agent? So what the world is like now, what it will be like if I do action A. If I do the action A, will I be happy or not? In the sense, if it is a human happy, if it is a machine, will I get best utility or not? This is what you will have to check. This is one more step. If you see, it is small evolution from that simple question. Simple question. Next is little more complexity, and we are moving towards taking a best decision for your environment agent couple. Okay, so this is an example. So what does it do? Sometimes you don't even know. So this is, say for example, this is a kitchen. What fan do they call it? I don't know. But exhaust fan, like a kitchen exhaust fan. Kitchen exhaust fan automatically switches itself on without anybody saying that, because it knows what is the best possible situation or environment it has to create. And even the thermostat temperature also. So if you see this temperature, it changes second by second. It is changing depending on the temperature in the room. It is changing second by second. So this automatic thermostats will be there, which will regulate themselves. You say this is my comfortable temperature. It will regulate themselves, saying that it will only take. So they all take these kind of machines, take their utility based agents, take decisions on their own depending on the environment. Finally, the last one we are going to talk about is the learning agent, which is the basis for machine learning. So the learning agent will learn from its past experiences. So what all it has a learning element. What element that you want them to learn? Like in the credit card aspects, we want to learn whether a person will repay the debt or not. That is the learning element there. So critic, how will I know whether it is something right or not? Yesterday we have seen that movie one, that is the critic. So you have put me that I will like that XYZ movie in my likes list, but I saw that I didn't like. So I marked dislike button there. So that is a critic. It takes feedback from it and learn from it, rearrange entire my interest data of Netflix again. That is critic. So performance element. So this one has to select the action. So which one you will have to choose? The speed for the car. What is the measurement of the performance? What is the final goal you have given to that? You have to reach there by 10 a.m. You have given that goal, or what is the performance element that you are measuring? Performance generator is the one which is the motor or the accelerator or the autonomous car is responsible for your for the performance of this, and the problem generator is responsible for suggesting action and which will give us the experiences. So these are the 4 items which are part of this learning agent. So same concept, sensors, but you have a critic. Performance standard is preset, and there is a critic which will give you feedback into the learning element. And your performance element, you will give those information to keep changing. Okay, and that knowledge you will be getting. So this you will have to understand a little bit. Probably it's 12:35. I want to stop. We'll start from here again. Tomorrow, as I said, is very important. The foundational principles for entire artificial intelligence machine is 2 things. Search, as I said, search is not for just searching one element. but that is what you use for building your neural networks, or even for anything. Search is the type of principle used for building artificial intelligence, not for searching things. And second thing is knowledge representation. That is day 4, where we'll be knowing knowledge representation. Day 5 is machine learning, which is okay, you'll get anywhere, but these are the foundational principles that you'll have to learn. So I will see you tomorrow. Thank you so much. For one very good thing I observe is all the people who are in the beginning are till the end. Thank you so much. And as I said in the beginning, please let us know if you will want to be part of Blackbuck's Turing Center of Excellence for Artificial Intelligence, which will be bringing you lots of knowledge webinars. That is just input. Output also, that means we will also be bringing consulting projects to you from the industry, and also would like, if any teachers are interested in delivering lectures, we would also provide you teaching consulting assignments. So if you are interested, please mark yes, and we will make you member in the in our Center of Excellence. Thank you so much once again. See you tomorrow.